The ketogenic diet has become pretty popular, and for the right person, it may be a great idea in the short or the long term. This presentation is not here to extol the benefits of this diet. My assumption is that you are already on it or contemplating doing it. That's your decision. My goal here is to further assist you if you choose to follow this diet. So let's get started. The origins of the diet actually go back 2,500 years. It was found that fasting was able to reduce symptoms in epilepsy. As you can imagine, fasting is not a long-term solution. It was in 1921 when a paper was published that explained how what we now call the keto diet could yield the same benefits of fasting in epilepsy without the downside of starvation. The original version of this diet required about 90% of the calories to come from fat, while protein intake is a little more than that of carbohydrates. One Granny Smith apple a day would be your limit for carbs. So what does this accomplish? Well, it changes the biochemistry of the body from a primarily sugar-burning organism and puts it into a ketogenic state, which mimics starvation. So what does the body do in starvation? It mobilizes fat stores, which is why it's a great idea for weight loss. But it also has a slew of other benefits, many of which you can see here. The mechanisms of action are listed. Now, there are two very general groups for this diet: long-term, like in epilepsy, and short-term, like in weight loss. This is an important distinction because an obese person with plenty of fat stores to draw upon, who may be on this diet for the short term, is less likely to suffer from side effects, if any, than a child who has to maintain this very restrictive diet indefinitely. So as you can imagine, given the restrictions, there are a number of possible side effects which are listed here. Obviously, these all don't apply to everybody, but it may be a wise choice to work with an experienced practitioner. Given the strict nature of the diet and the possible adverse events, a number of different versions have been introduced, which makes a lot of sense. I would be challenged to get 90% of my calories from fat. These versions have different names, but the idea is generally to keep the carbohydrate intake very restrictive, but reduce the fat requirements and up the protein. Although these diets work, we run into real-world obstacles. Many people work and have busy lives. Many others will fall into the idea that they can eat all of the bacon, sausage, and pork rind that they want and just be fine. So the goal is to get you the results you desire, given the lifestyle you lead, but without compromising your health. And notwithstanding the fact that bacon, sausage, and pork rinds are bad for your health, the diet is generally not good for your microbiome. If you're familiar with any of my presentations, you now understand how the microbiome is tied to your health in so many ways. So let's take a look at that. Since all this started with epilepsy, we'll start there too. 12 subjects started a keto diet, and 5 of them were responders concerning seizure frequency with greater than 50% seizure reduction. 3 patients, though non-responders concerning seizure frequency, had shorter seizures. 10 children were responders concerning cognition and motor function. Clearly, the diet helped a great deal for epilepsy. However, the dietary effects on the microbiome were detrimental. These children had significant reductions in 2 key health-promoting taxa, the genus Bifidobacterium and the species E. rectale. What was increased was the classic opportunistic pathogen E. coli. Since the ketone bodies beta-hydroxybutyrate, acetoacetate, and acetone seem to be so beneficial in neurological diseases like epilepsy, the keto diet has been recommended for dementia. But if we look at my meta-analysis of the 24 human fecal microbiome studies I used for dementia, I get these following results. This is the fecal microbial fingerprint for dementia. The healthy controls, denoted in green, consistently had significantly more of classic health promoters like E. rectale, F. prausnitzii, Roseburia, and Ruminococcus in their microbiomes as compared to dementia subjects, whereas the dementia subjects had significantly more species from Enterobacteriaceae, which is the worst family in the GI tract, which is usually represented by E. coli. But the problem is that a high animal fat, high animal protein diet promotes the dementia microbiome and does not promote the healthy bacteria we see here. Let's see another example. The keto diet is also recommended for Parkinson's disease, which is a disease with a number of similarities to dementia. See my presentations on dementia and Parkinson's for more information. As we see here, once again, the bad actors in Parkinson's, represented in orange, like Streptococcus, Lactobacillus, Enterococcus, and Escherichia, that's where E. coli comes from, are significantly higher in the diseased subjects, while classic health promoters, such as F. pausitzii, Carpococcus, Roseburia, Ruminococcus, Blautia, and Fusicatenibacter, are virtually always significantly higher in the healthy controls. But again, a diet very high in animal fat and protein does not feed these good guys. It feeds the bad guys. Let's do one more. When I chart all the data points that I have for obesity and type 2 diabetes, I get this slide here. Again, we see the superhero of the gut, F. pausitzii, is almost always significantly higher in healthy controls, in trials where a significant difference was found. Whereas Lactobacillus and the family Enterobacteriaceae, which we covered earlier, and is mostly represented by E. coli, are higher in obesity and diabetes. Once again, a high animal fat and protein diet feeds the bad actors, thereby promoting disease. So biochemically, the diet works on so many levels, but at the expense of the microbiome. If it's a short-term plan, you can recover, but what if it's not? And what if I told you you could have the best of both worlds? Let's see this diet in action. In this study, the animal-based diet did result in weight loss. Great. But it also increased the number of bad actors like Clostridium botulinum, Ruminococcus navis, and E. coli, while it decreased universal health promoters like Roseburia, Eubacterium rectale, and Ruminococcus bromii. The animal-based diet also increased the expression of beta-lactamase genes, which enable a bacterium to be resistant to a broad array of antibiotics. These genes just didn't come out of nowhere. Their expression was increased given the environment of the microbiome, epigenetics. The diet in this trial wasn't even keto. It had more carbs than normal, so they called it a low-carb diet. Nevertheless, the subjects still lost a bunch of weight, but still had significant shifts in their microbiomes. Highlighted in Table 3, you can see decreases in many health promoters, like Subdoli granulum, Ruminococcus, the amazing family Lactobacillus, E. rectale, now called Agathobacter rectalis, E. hallei, and Bifidobacterium. And in this in vitro study, again, classic health promoters were significantly decreased in a protein-rich environment. Great bacteria like Ruminococcus, Subdoli granulum, E. rectale, Anerostipes, Lactospira, species from Eubacterium, and Roseburia. So why are these high animal fat and protein environments not suited for the good guys and suited for the bad ones? Here is one of the best papers you'll ever find on this topic. These researchers performed a pooled analysis of 2,387 metagenomic transcriptomic samples from 15 publicly available datasets originating from 3 continents. So what's the takeaway? As I always say, the short-chain fatty acid butyrate is critically important, especially for the gut. And the most health-promoting bacteria are butyrate producers. But not all butyrate producers are health promoters, like F. nucleatum and Flavonifactor plaudii, but most are. There are 4 main pathways to produce butyrate in the microbiota. 3 of them use protein for fuel. Only 1 uses carbohydrate. This is the acetyl-CoA pathway. This is where most of your amazing universal health promoters reside. If you're only eating fat and protein, you're not feeding them. And so their abundance drops, and they can't do good things for you. These authors go on to state, among other things, that the majority of taxa from this pathway were associated with the Firmicutes families Lactobacillus and Ruminococcaceae. So let's take a look at these 2 families. This slide is accumulation of thousands of hours of work, determining the key players in the microbiome. Collected here are the great universal or almost universal health-promoting taxa of the gut. These health-promoting bacteria have been found to be consistently, significantly higher in healthier cohorts and significantly lower in the unhealthy ones across all diseases. The darker the green, the stronger the data as a health promoter. Out of 1,000 or more species in your gut, this handful plays an enormous role in your health. Almost all of these are from the families Luminococcaceae and Lactobacillus, as you can see. There are a few health-promoting genera not listed here, like Bifidobacterium, Allostipes, and Odoribacter, which are in other phyla. Allostipes, Oecilibacter, and Odoribacter have mixed data in Keto because although they are health promoters who produce butyrate, they are the only 3 genera listed here which make butyrate from protein exclusively in the case of allostipes or contain mixed pathways for the other 2. Neither Bifidobacterium nor Arabromii make butyrate, but are clear health promoters. Now, which of these taxa have been shown to be significantly reduced in a high animal fat and protein diet? These. Not only are the good guys not getting their fuels to flourish, the bad guys are getting theirs. So now let's tackle protein and fat separately. First, protein. When we ingest more protein than we can handle, some makes its way past our absorptive abilities in the small intestine and makes its way into the large intestine. This is especially the case when using PPIs. Even in the distal small intestine, there's protein fermentation. The primary bacteria related to protein metabolism in the small intestine consist of Klebsiella, Escherichia, and Streptococcus species. These are all opportunistic pathogens, bad guys. Then, once in the large intestine, fermentation continues. The amino acids can be fermented to create short-chain fatty acids, or a number of toxic compounds, such as branched-chain amino acids, hydrogen sulfide, ammonia, and phenols. There are 3 types of amino acids fermented. The sulfur-containing amino acids, cysteine and methionine, are fermented to produce sulfur compounds, particularly hydrogen sulfide. Second are the aromatic amino acids, tyrosine and phenylalanine, are fermented to phenolic compounds that include P-cresol. Third are the aromatic amino acids, E. coli, Salmonella enterica, Enterobacter species, Enterococcus species, Peptostreptococcus species, Fusobacterium species are able to ferment sulfur-containing amino acids. These are all bad guys. Anaerobes known to ferment aromatic amino acids and generate phenols such as P-cresol include Bacteroides species, Lactobacillus species, Clostridium species, and Peptostreptococcus species. Some of these are bad actors as well. The ammonia, P-cresol, and hydrogen sulfide have all been shown to damage the cells that line the gut via a number of mechanisms. Do you know we also see a lot of these protein fermentation end products along with strychlin metabolites, which is another marker for protein fermentation, in C. diff infections, the extreme case of dysbiosis. Do you know what changes this whole process? Fermentable carbohydrates, as in prebiotics. The prebiotics that I recommend have sugars locked behind bonds that we can't access, but the good guys in the microbiome can. Multiple studies show that when administered, all these toxic markers of protein fermentation are significantly reduced. Take ammonia, for example. Increased carbohydrate fermentation and bacterial growth can decrease ammonia concentrations in the gut due to higher incorporation of nitrogen into microbial cells. This in turn decreases the luminal pH, a good thing. Bacterial proteases work best at a neutral pH, but we don't want a neutral pH because the good guys get outcompeted there. We want a little bit less. With that said, here I have a few in vitro studies which reinforce the very important topic of pH. These researchers used 4 different levels of acidity in a controlled in vitro environment to measure the growth of various bacteria using the common prebiotics inulin and pectin. This is with prebiotics, not protein, but still highlights pH. At varying levels of acidity, different bacteria can outcompete others. They state that, quote, at pH values closer to neutrality, that'd be 7, our evidence suggests that other bacteria will tend to outcompete Bifidobacterium for inulin. At higher pH values, the good guys get outcompeted. For example, in the second to last point, Eubacterium rectale, which we've heard a lot about so far in this presentation, which is incredibly beneficial, appears to be inactive and outcompeted at a pH of 6.7, but it's very happy at a pH of 5.5. Again, speaking of erectile, here these researchers showed the exact same thing. E. coli was hindered at 5.5, but E. erectile grew very well at the same pH, but was undetectable at 6.7. You can see to the right the drastic differences in the colored circles, which reflects the abundance of different members of the microbiota. This radical change is driven by a change in pH, from at either 5.5 or 6.7. And not only are the bacteria themselves changing, but their byproducts as well. Here we see drastic changes in the all-important butyrate, shown with black circles, from 2 donors as we shift from a pH of 5.5 to 6.5. They attributed, at least in part, the reduction in butyrate to correlated reductions in Roseburia. Roseburia is an incredible genus with excellent data points and reduced on a strict keto diet. The goal is to create a microbiome with a pH in the Goldilocks zone of roughly 5.5 to something just shy of 6.5. A high-protein diet gets us higher than that. So now let's look at fat. Instead of looking at the shifts in bacteria in the high-fat diet, we'll look at another important factor. But first, suffice it to say, there is proof that a high-fat diet, especially high in saturated fats, has been found to cause dysbiosis, inflammation, and LPS translocation into the body. Spikes in LPS, aka endotoxin, in the blood have been seen in multiple studies following a high-fat meal in healthy subjects. Now, LPS is always present in our blood, but at low levels. So what's going on here then? There's enough evidence to show that the process of absorbing a high-fat load is damaging the cells that line our gut. The increased requirement for the chylomicron-led absorption of lipids distends intercellular space during the process, which seems to loosen the bonds between the enterocytes, the cells that line the gut. And although this is a temporary event, it allows quantities of LPS to enter circulation. And the key culprit for this inflammation destruction is long-chain fatty acids. And if you've been watching my presentations, you should know that systemic LPS, as well as parts of other bacteria systemically, are highly problematic for our health in so many levels. I want you to have the best of both worlds, to get the clinical results you're looking for, while at the same time maintaining the health of your microbiome and the rest of your body. Because keep in mind, your microbiome is closely related to the conditions you're trying to resolve with a keto diet. For more on that, watch my presentations on dementia, Parkinson's, and obesity/metabolic syndrome. A dysbiotic microbiome with serum LPS is at the heart of these as well. The intelligent use of properly blended and dosed prebiotics will not hinder your results, but in fact, they will help. Prebiotics are keto compliant. We don't absorb the sugars within. They don't count towards your daily carb intake. But when those sugars are fermented by those amazing bacteria we discussed earlier, a number of fantastic things happen. One of which is an increase in your satiety hormones. That's right. If your goal is to lose weight, then you'll feel less hungry as well. If you found this presentation informative, I have many more for free in my YouTube channel and also in the Microbiome University tab on my website, themicrobiomeexpert.com. There you can select from a wide variety of topics. And if you or a loved one are struggling with a disease/condition, I have condition-specific presentations as well, along with their microbiome protocols found within its respective tab on my website.